previously we did the DTFT. Now DTFT works this way. So when you have a signal, and you notice, and let me have a new one here. Okay, in DTFT, it stands for discrete time Fourier transform. Now you notice our data was in n format. So I have x of n. I will get x of ej omega. Now remember, square brackets mean discrete. So it's a discrete time. Now, continuous brackets, what do I have? I have continuous function. So DTFT, I will go from discrete time to continuous Fourier domain. Now we will have DFT. Now it's a discrete Fourier transform. In this one, I will have x of n. I will get x of k. Now, what is the relationship between DTFT and DFT? DFT, it sounds like, or it looks like a sampling or samples from DTFT. So this is just like a warm introduction. Let's go into the details. So introduction to DFT, discrete Fourier transform, and the inverse of DFT. What is the relationship between both DFT and DTFT? Then we'll talk about the algorithm, the fast Fourier transform, some properties, and some uses and applications. Okay, so looking at the expressions here, so DFT results from taking frequency samples of the DTFT, which we had learned previously. Sampling is done such that continuous frequency variables are sampled at n equally spaced frequencies. The limits in the DTFT sum must be finite. So here I must have points from n to n minus 1. Those are my Fourier points, my samples. So the value of k ranges from 0 to n minus 1. So if the transform length k is greater than the signal length n, zero value samples are appended to the signal in order to make it longer and match the transform length. This process is called zero padding. Now, what we mean by that, so usually if my signal, the length of my signal n equal 5, so k must have 5 values, or uppercase n. That's my Fourier points. However, if my signal, let's say, has 3 points and I ask for 5 points, I will add 2 zeros for that signal. So something like this. If my signal is 1, 2, 3, and I will ask you find the 5-point Fourier transform. So I will make it then like this. Now, where's the eraser? Here. So we will do the process that's called padding. I will add zeros to the signal. So I have 5 points in time, so I get 5 points in frequency. Best way to do it, let's apply an example. So compute the 4-point DFT of x of n 1100. So let me copy the formula there. Control C. I'll do it here at the whiteboard. Control V. And let me take the question. Copy it and paste it here. All right. So this is a typical question you might face in the exam. You will be given the task and the formula is there. You just need to apply it. So nothing complicated, inshallah. All right. So now it's a 4-point DFT. So n, my number of points is 4. Now the values of k should be 0, 1, 2, 3. So I need to repeat this formula 4 times. Add k equals 0, add k equal 1, add k equal 2, add k equal 3. And that's it. So let's apply at k equals 0. So I will get x of k equals summation n equals 0. Now the lower case n, that's for the point in here, 2, 3. Why? Because it's n minus 1, 0 to 3. Now x of n e to the power minus j 2 pi over n over uppercase n times k n. Now k at the first case is 0, so this exponent is gone because this one equals 0. So my summation will become n equals 0 to 3 x of n. So basically it's the summation of all elements of n. That's going to be simply 2. Is it clear what I did here? All is clear. Just apply the formula. I set k for 0. Now I just remove it from it made the exponent become 0. I just substitute the values. Okay, so that's the first one. Now at k equal 1. So I will have x of 1 equal n equals 0 to 3 x of n or minus. Now let me substitute, make the expression simpler. It's going to be j 2 pi over 4 because n is 4. So this is j pi over 2 minus j pi over 2 k n. And k here is 1. So it's gone. So my expression will become n equals 0 to 3 x of n e to the power minus j pi n over 2. Now let's write it. So at n equals 0, it will be x of 0 e to the power 0 plus x of 1 for minus j pi over 2 plus x of 2 e to the power j minus j pi plus x of 3 e to the power minus j 3 pi over 2. Okay, so let's simplify. X of 0, it's 1 times 1, that is a 1, plus x of 1, it's 1 times e to the power minus j. So it's going to be e to the power minus j pi over 2 equal cosine pi over 2 minus j sine pi over 2. It's going to be minus j. So this whole thing, it's minus j. I don't have to put the exponential form. So times negative j. Plus, now x of 2 is 0, so it's gone. And same thing for x of 3, plus 0. So the answer is 1 minus j. Is it clear for this one? Is it clear? Any questions?
No, doctor, it's clear.
All right, perfect. So let's go at k equal 2. You will get x of 2 equals summation from 0 to 3 and equal x of n e power minus j pi over 2 times 2n, because k is 2 in this case. Okay, so 2 and 2 will be gone. Now my expression summation n equals 0 to 3 x of n e to the power minus j pi n. So let's substitute. I will get x of 0. And the first expression is always x of 0 because n is 0 plus x of 1 e to the power minus j pi x of 2 e to the power minus j pi 2 pi plus x of 3 minus j3 pi. Again, x2 and x3 are zeros already. Don't forget your question. That's x of 0. That's x of 1, x of 2, x of 3. So they are zeros. All right, so in this case, 1 plus now x of 1 minus e to the power minus j pi cosine pi minus j sine pi. So that's going to be negative 1. Cosine pi negative 1, and I have a 0. So that's a negative 1. So in this case, the answer will be 0. Since the question is already solved, I'll move on. So the first value was 2. I believe that's what we got here. 1 minus, that's a 2. And the other one, 1 minus j. You don't have to do this. You can keep it in Cartesian coordinates. You don't have to represent it by magnitude and phase or the polar coordinates. So the third one is 0. The last one is 1 plus j. So the final answer you represent it like this: x of k equals 2 1 minus j 0 1 plus j. So that is the final answer. Okay. Now the inverse discrete Fourier transform, similar expression. You probably guessed it. So negative exponent will become a positive exponent, and you divide over n. Similar thing here, but you swap between the n's and k's. Again, formula will be given in the exam. You just need to apply the values. So for the same exact problem that was previously shown, you have the values given here. Apply, and you should get the same exact function 1 1 0 0. So in the exam, make sure to practice both examples, because literally the scope of the exam will not be beyond these two concepts. Some pairs or some comparison between DFT and DTFT. So in terms of time duration, Fourier transform should be finite, and the Fourier series is the same thing. Discrete time, and same thing here. Let's not worry about these conceptual topics. How to get the DFT from the IDFT? It's possible to construct the DFT pairs by making substitution. As an optional step, you don't have to worry about it. Okay, from IDFT again, let's not worry about these concepts. There is a formula or an algorithm to make the fast Fourier transform, or sorry, the discrete Fourier transform fast, because you have seen now it's a lot of calculation, and we are dealing with only 4 points. Usually data points are in millions, especially sounds, and like images will be even worse. So they developed the algorithm of the fast Fourier transform to accelerate the process of the DFT. And in MATLAB is a simple command FFT. Inshallah, next week we'll do a MATLAB session to cover all the concepts that we missed. Someone is trying to join.
دكتور next week
Yeah,
is the last week صح؟
Last week we'll do a quiz. I'll send you an email about the material of the quiz. We will also do a MATLAB kind of workshop that will help you on the project.
project.
Yeah, there is a project. But it's not very complicated project. You just need to pay attention during the lecture and things will be easy inshallah.
يعني بنسوي في اللكتشر البروجكت يعني دكتور.
Yeah, we'll work on it in the lecture, but the submission and the report and the presentation, you'll do it on your own. But mainly I'll do the explanations during the class.
إن شاء الله.
Inshallah. All right. So basically the fast Fourier transform, you're dividing the whole problem into sub-problems, do a solution, then accumulate the solution. So properties for the DFT, periodic over the K, and N, let's not worry about just properties. I will not ask you in the exam. Convolution in time domain equal multiplication frequency domain. Similar thing applies here. So multiplication in time domain, that's convolution frequency domain, and the opposite. Okay, the energy Parseval theorem. It means that the energy in time domains equals the same energy in frequency domain. So that's properties. Pairs. We don't do much pairs here. Actually, just to do the first, these two examples, just solve them, understand them, and everything should be clear. Now we'll see the worksheet, what information it can provide us. Some applications DFT, usually in image processing. If we deal with image processing, like these things mean a lot. Actually, it's not just a grayscale image. And that's it. Some advantages, disadvantages, etc., etc. So let's go to the worksheet. Okay, so discrete Fourier transform. Compute the Fourier transform here. So this is the formula. Now let's compute the 4-point DFT, compute the 3-point DFT. It's the same previous example, but now different data points. Compute the 4-point inverse DFT for these points. So again, nothing magical in this lecture, just direct application to the formula is given. Worksheet has already been solved. The solution is here already. And the answers are clearly stated there. Again, like when you do this 4-point DFT, you don't have to do the polar form. In the exam for me, that's enough. Like once you get 1 minus j, that is enough for me. Similar thing for the other tasks. Okay. And that's it. I did not guess this lecture will be fast, but alhamdulillah. Next week, inshallah, probably before next week, I'll prepare like a demo or an illustration of the project. So you can have it as a reference. So you can work on it. Because I don't want you to create the whole MATLAB code from scratch. I need you to understand what's going on in the code. Basically, the task will be denoising. Like you'll be given a noisy signal, noisy audio signal, and you need to denoise it with certain filter properties. All right, so that's it. So stop sharing. And if you guys have any questions, feel free to ask. تفضل.
When will I record?
I'll send you the links. I will not put them in YouTube because I don't have the complete course. So I'll send you the links on email.
All right, okay.
Oh, actually, even when you leave, just go to the chat. A screen is shared now. Okay, see here the chat, our class. So go to the Teams. If you open Teams, you should go in Teams. You should see something like this. Whoever put you there, probably I'm the only one. So this is our course. Go here and go to the general chat and see the replies there. There you go. So that's the first recording. Once we are done, the second recording will be there. So let me stop
Fine.
recording because anyways, I'll still put them in my shared drive and send you the link.
All right, okay, very well, doctor.